Good morning. We are continuing on working with our angles. And today we're going to use those angles to classify triangles. So we are doing CO54. I can classify a triangle by its sides and angles. So there are two different types of classifying. One type, we look at those angle measurements, and there are special names that go with angle measurements. The other way is looking at our side measurements and classifying by the sides. So two different ways of looking at triangles, and it's important to keep them separate. Sometimes you're given side names, sometimes you're given angle names, and you need to know which goes with which. So first we need to define what a triangle is. A triangle is a polygon with three sides and angles. Angles always sum to be 180 degrees. Okay. So it's a polygon, so that means all of the sides connect. There's no open side. They all connect. There are three sides, three angles. Now this is important as we're working with triangles. When we add up all three angles, it will always equal 180 degrees. Doesn't matter what name we give the triangle, those angles will always add up to be 180 degrees. That is a magic number working with triangles. You need to remember that, 180 degrees. Magic number. Okay? This is going to come in use in the next few objectives. So there are different types of triangles and are classified by their sides or their angles. Let's take a look. So our first type is classifying a triangle by its sides. Does anybody know from previous classes what a scalene triangle is? Think you know, Rhoda?
With one side bigger than the other two, or one angle bigger than the other two?
It's a good guess. That is not right. What's your guess, Presley? Say it a little louder. Yes. All the sides are a different length, so there are no congruent sides. What does congruent mean? Jude? The same. No sides have the same length. They are all a different length. So when we look at a scalene triangle, it could be something like 4, 6, 8. We don't look at angle measurements with the scalene. Scalene triangles are classified by their sides. So we just look, do we have side measurements? They are all different lengths. Does not matter what their lengths are. They could be any numbers as long as they all three are different numbers. Next is an isosceles triangle. Anybody remember that triangle? What would an isosceles triangle look like? Give it a go, Michael.
Two sides are the same and one side's different.
Two sides are the same. Whoops, let me write it first. So we have two congruent sides. So what that looks like is we might have a 7 and a 7, and that's a 4. Two sides are identical, one side is different. Sometimes you might see it with that hash mark there. That hash mark is the same on two sides, that means their measurement is the same, that they are congruent. I don't know why that erased. Okay, so scaling, none of them are congruent, all different numbers. Isosceles, two sides are the same, one is different. What about an equilateral triangle, Alex?
They're all the same.
All three congruent sides. They are all the same length. Lateral means side. Okay, that is going to be different than the equal angular. Equal means equal, right? Equilateral, we're looking at our sides. All three sides have the same measurement. Notice how my numbers are going right with those sides. And if I'm using those hash marks, there's one hash mark the same on each side. Okay, so you could just do the line on each side showing that all three are congruent, or you could put the measurement. The measurement needs to be on the side, not as an angle. I'm emphasizing that because that's a mistake friends make every year. Side triangles, you have to put the measurements on the sides. So angle triangles, when you're giving an example of an angle triangle, you have to put the degree measurement in the angle. Okay? Any questions on our three side triangles? All right, so let's look at our four angle triangles. Our first one is an acute triangle. Think about what we know about acute. How do you think that applies to a triangle? Jack?
Did you add up the degrees on the triangle?
The degrees will always equal what?
Oh, right.
It's gonna always equal 180, so we're not adding anything up.
Like the way, I don't know.
Okay, give it a try, Rhoda.
The angle is going to be an acute angle?
Which one? You said the angle. How many angles are in a triangle?
3.
Could we have just one acute angle? We have to think of all three of those angles. Michael? All three angles are acute. So it has three acute angles. So when you draw an example, all three of those angles need to be less than what? Joy? Less than 90 degrees. Here's the trick. What do all three of those angles have to equal? Michael? 180. So when I put in my examples, like up here, I put in examples for my side lengths. When I put in measurement examples, degree examples, they have to all three equal 180, but they all three have to be less than 90 degrees. They all have to be acute. So I could say maybe this angle is 40 degrees. Maybe this angle is 80 degrees. And this angle would have to be what?
60.
Because 40 plus 80 is 120. 180 minus 120 would be 60 degrees. So notice how my degree, angle degrees, is pointed right into that angle in the triangle. Sometimes you can write it right inside of that degree, but when it's acute, it gets really little. So you can just draw a line showing that it's that angle measurement. You need to add all three up to make sure they equal 180 degrees. And you need to make sure that it's acute, so they're all less than 90 degrees. So with the side lengths, it's not as nitpicky. With the angles, it gets picky because we have to equal 180 degrees. I have had kids lose points on the test because they didn't make sure they all equaled 180. They did 20, 30, 40. 20 plus 30 is 50. 50 plus 40 is 90. I can't give credit for it because we have to know that all the degrees always equal 180. You have to pay attention. Our next one, a right triangle. What do you think that means? Rhoda, give it a try. One right angle. Why just one? With the acute, they were all acute. Why can't I have them all right angles, Jack?
Because it would be like a square.
Ah, I have one right angle. If I want to make another right angle, all of a sudden it's not a triangle. So I can have one right angle, but only one if it's a triangle. I need to put something in there to show that it's 90 degrees. You could either put the box that shows it's 90 degrees, or you can put the measurement that it's 90 degrees. But then I have to put measurements for the other two angles. What could I put there? Vinny, give it a try.
30?
I could put 30 for this one. What would I have to put for that one then, Vinny?
30?
So if I have 90 plus 30 is 120. 120 plus 30 is 150. 90 plus 30 is 120. What does that third measurement have to be? Yeah, I have to make sure that all three measurements equal 180. Have to. Triangles always equal 180 degrees. Okay? Obtuse triangle. Haley. One obtuse angle. Now remember, an obtuse angle is going to be bigger than 90 degrees. So you have to have a big angle. Only one of them can be obtuse because if I put another obtuse angle on there, it's not going to be a triangle. So it can only have one obtuse angle. What might be a measurement I would put in there? Rhoda?
100.
100. As long as it is bigger than 90 degrees. Okay, because it's obtuse, it has to look bigger, and it has to have a measurement bigger than 90 degrees. So what could I put in my other two angles? Matt?
40.
If I put a 40 here, what does this one have to be?
40.
Another 40, because 40 plus 40 is 80, plus 100 is 180. So you have a little leeway on what measurements you put, but that third measurement has to be a certain number because we have to equal 180 degrees. Our last one is an equiangular triangle. Think about what we know about the equilateral triangle. What does equiangular mean, Michael?
All the angles are the same.
3 congruent angles. do our angle measurements have to be. I can't just say 20, 20, 20, because that only equals 60 degrees. There is a specific angle measurement that they all have to be. Do you know, Jackson? 60. Because 60 plus 60 is 120, plus 60 is 180. If it is an equal angular triangle, all of them have to be 60 degrees because they have to be the same and they have to equal 180 degrees. Any questions on our angles, angle triangles? All right, so let me scroll up. On the bottom it says classify each triangle by its angles and its sides. So you're going to give two names. You're going to give an angle name, you're going to give a side name. So let's look at our first one. What would its angle name be? Look at those 4 angle names. Look at those angle measurements. What name fits it, Presley? That is not an angle name. So look at those angle names, those 4 angle names. They're all acute angles. Now I have to do its side name. Presley, what's its side name? Isosceles. Because all the angles are smaller than 90, I know it's acute. And because 2 sides are the same, I know it is isosceles. You're going to do the other 2 on your own. Then let's look at our second page. Our second page, we have to draw this triangle. So it has to be acute. So all 3 angles need to be smaller than 90 degrees. And it's scaling. So all 3 sides have a different measurement. So you have to make sure that you're putting labels in for the degree angles and you're putting labels for the sides and that they match what the name is. Then we're going to have some true false. So read through it, decide, is this true, is it false? If it is false, say what makes it false. And then we have review on the bottom. If you don't remember any of those vocab words, go back to those objectives and look them up. If you are watching at home, I hope you are well, and I hope to see you soon. Have a wonderful day.